In this video, we're going to go over how we can solve equations by equating coefficients. So we're asked to find the values of b, c, and r. To solve this, there's a long way and a short way. And I'll go through the long way first because this is probably what your textbook has. And to equate coefficients, we want both sides to be in the same form. And we do this just by expanding the brackets in the right-hand side. So to expand this, we just go x multiplied by x squared plus x times bx plus cx, so c times x, then minus 2 times x squared, minus 2 times bx, and then minus 2 times c. So that's the brackets expanded, and then we just add the r at the end because that was outside the bracket initially. Now what we want to do is we want to group the like terms together. So all the x cubes go together, all the x squareds go together, all the x's go together, and all the constants go together as well. So I'm just going to rewrite this equation so I have all the like terms next to each other. And then what we're going to do is we're going to take out the common factor. So we're factorizing by grouping here. So for x cubed, since there's only one term with x cubed, that just stays the same. Then we have bx squared minus 2x squared. So what we can do is we take out the common factor of x squared. So it's b minus 2 in brackets, and then we multiply that by x squared. And then we look at x. We have cx minus 2bx. So here we can go x, take that out the front, and then we have c minus 2b. And then finally, the constants, which are basically the pronumerals that don't contain x, that's just negative 2c plus r. Now what we want to do is the equating coefficients part. So this is where we look at the original expression, so x cubed plus 3x squared plus 2x plus 1, and we match each of the coefficients to the coefficients in this new term that we have here. So the x cubed, in this case, they're the same term, so there's not much to do there. But for a term like 3x squared, we match the coefficient, so 3, with the coefficient of x squared in the other term. So we want to equate 3 with b minus 2. And then we want to equate the coefficients of x with each other. So we have 2 in the first equation, and we have c minus 2b in the second equation. So we write 2 is equal to c minus 2b. And then finally, we want to equate the constants together. 1, and we have minus 2c plus r. Now, looking at these equations, the first one only has one pronumeral, so we can solve this just by moving the 2 to the other side. So we get b is equal to 5. Now that we know that b is equal to 5, we can just sub in this value into the second equation. So if we rewrite that, we have 2 is equal to c minus 2 times 5, which is 10. And that means c is equal to 12, just by moving the 10 over. And now that we know that c is equal to 12, to solve the third equation, we can just sub in c is equal to 12. So we get 1 is equal to negative 2 times 12, so negative 24, plus r. So in this case, r is equal to 25. So these are your three answers, and this was the relatively long way to do it. Now, there's a much shorter way to do this that doesn't involve expanding out every single term. So basically what the short method is that we want to substitute a couple values of x to help find the unknowns. And in terms of what values you want to substitute, this completely depends on you. But there are some things that make it a lot easier. The first thing you should pay attention to is there a value that you can substitute to make one of these expressions equal to 0. For example, if you substitute x is equal to 2, this first bracket would be equal to 0. And this will make this entire expression here equal to 0 as well. So that means we're just left with r. And then we look at equation 1. If x is equal to 2, so let's just sub in x is equal to 2 for each of these. So we have 2 cubed plus 3 times 2 squared plus 2 times 2 plus 1. And if you evaluate that, you get 8 plus 12 plus 4 plus 1, which is 25. And that's what we got in the other method as well. So now that we know what r is, what are some other values that we can substitute? As a general rule of thumb, you want to substitute values that are small because this will make doing the question a lot easier. So for example, 0, 1, or -1 are all values you can choose. Now, starting from 0, this is probably your easiest option. Let's just start from the left-hand side this time. Basically, everything that has an x in it becomes 0. So on the left-hand side, we just have a 1. And then on the right-hand side, we have 0 minus 2. So that's in brackets. And then 0 plus 0 plus c. And then plus r at the end. Now, expanding the brackets, this is much simpler than the case we had before. So in this case, it's just -2c plus r. But we know what r already is from our previous conclusion, which is 25. So we know that 1 is equal to -2c plus 25. And if we evaluate that by moving 25 to the other side, which gets you -24 is equal to -2c, we get c is equal to 12. And then finally, since we've subbed in x is equal to 2, x is equal to 0, next we try x is equal to 1. So on the left-hand side, we just have 1 plus 3 plus 2 plus 1. And then on the right-hand side, we have 1 minus 2 times 1 plus b plus c, and then plus r at the end. So evaluating the left-hand side, we have 7. And on the right-hand side, let's just sub in the values for c and r. We know that c is equal to 12 and r is equal to 25. So we have 12 minus b on the right-hand side, and on the left-hand side, we have 7. So solving this, we end up with b is equal to 5, which is what we got using the other method as well. So this is how we can solve equations using equating coefficients. There's a long way and a short way. With the short way, always substitute values that will make one of the expressions or one of the brackets equal to 0 first, and then after that, try and substitute the smallest number possible. Usually substituting 0, 1, or -1 will do the trick.